Okay, on this next equation, I'm going to go ahead and find the inverse. So remember, to find the inverse, I'm going to end up switching x and y. So I'm going to have x equals log base 5 of y minus 3 with a plus 2 on the end. Now, to find this inverse, I'll subtract 2, so that gives me an x minus 2 is log base 5 of y minus 3. Now, in my quest to get y by itself, I'm kind of stuck here. I cannot go any further without removing this logarithm, and the way to remove the logarithm is to rewrite it as an exponential. So when I rewrite it as an exponential, my base is 5, my base stays put, but then the other two expressions switch places, not just the x and y, but the entire expression. So this x minus 2 goes over here as the exponent with the 5, because the logarithm was equal to an exponent. And then the y minus 3 goes there. So you notice the base stays put. It's the other expressions that switch places. Then to finish this up, I need to add 3. So that means my equation turns out to be y equals 5 to the x minus 2 with a plus 3 on the end. Now, in this case, I'm ready to graph this thing. Might want to make a table of values, but here's a few things I know. I know that my normal exponential would have gone through the point 0, 1, but because that has a minus 2, I know this thing has been shifted to the right 2. So that graph, instead of going through the point 0, 1 like a normal exponential, would have gone over 2, but it also has a plus 3, so it's also been shifted up 3. That means the asymptote that normally would have been at 0 is now up at positive 3. So I've got an asymptote kind of there. And then the point that normally would have been at 0, 1 has gone right 2 and up 3, so it's now at 2, 4. Now the reason I mentioned that is if I were going to plug in some other values, if I plug in a 2, that gives me 2 minus 2 is 0. And then 5 to the 0 power is 1 plus 3 is 4. That's exactly what I got. Then plug in some other numbers near that 2. So plug in 3. 3 minus 1 is 5. 5 to the 5th is 5 plus 3 is 8. So I have the point 4, 8 is on up here. And if you wanted to go 1 on the other side, you could have plugged in a 1. And that's going to give you a 5 to the negative 1 is 1/5 plus 3 is basically 3. So what you have coming on here is you have a very, very steep exponential curve that's been shifted a good bit that way. Now, to get the logarithmic function, what I'm going to do is I'm basically going to switch those. So instead of having a horizontal asymptote at y equals 3, I'll have a vertical asymptote at x equals 3. So the first thing is to get the asymptote in the right place. There's x equals 3 as my asymptote. And then instead of this point being, let's see, on this one we said we had a point of 2, 4, and also another point of 4, 8. I'm sorry, 3, 8. So I'm going to have a point of 4, 2 over 4 up 2. And then I'm also going to have a point of 3, 8. Instead of 3, 8, I'm going to have 8, 3. So I go over 8 to get up 3 way out here. So I'm also going to have a very steep backwards L-shaped graph coming right up next to that. And once again, anytime you have inverse functions, by the way, if you took this line y equals x, this perfect diagonal going straight through the middle, it is true that you should be able to fold the graph along that perfect diagonal y equals x, and the purple logarithmic part should lay right on top of the green exponential part if you've graphed it correctly. Now, it's great to be able to do these by hand, and you're welcome, but I'm going to show you how to do this last one using Desmos. So I have a log base 2, so go to your functions, pull up your log with a base, log base 2 of x plus 2 minus 1. That's enough where I can see that it looks like this thing has an asymptote really close to negative 2. Because of that 2, I'm suspicious that that's what's there, because that would have shifted it to the left. And if you try x equals negative 2, you can confirm that the asymptote is correct.